Take 47, balancing redox reactions. Okay, I'll try to get through this one. All right, what we're going to talk about is we're going to talk about balancing redox reactions, how you do it, how you recognize them, and going through the process, okay? If you've looked through the module, you see, you got to this one section and you just didn't see how to do it. And it has to do with, these aren't the kind of things you can balance just by inspection. You cannot balance a redox reaction by inspection. The way you notice what a redox reaction is, you'll see the following words in the question somewhere. They'll say, balance the following reaction in acid. Or they could say in base. They could say either one. They won't say both. They say one or the other. But they'll say balance the following in acid. That typically indicates it's going to be a redox reaction. Okay, redox reactions, you have to follow a process, okay? It's very formulaic. If you follow the steps, if you just go through the steps, starting with step one, it's very straightforward. It's mathematical, and so it works pretty quick. Okay, so let me go through the steps. I'm going to show it to you, and then I'm going to show you a reaction after that. Okay, step one. Oh my gosh. Okay, we're going to split into half reactions. Okay, so we're basically going to split the reaction up. We're going to split it up into two smaller reactions. And again, think of the arrow sign kind of as an equal sign. So everything on the left equals everything on the right in terms of just atom counts. Okay, so we're going to split into half reactions. It's going to be based on keeping your non H's and O's together. You'll see. We'll get into that in a second. But you're just going to keep things together. You'll keep your chromiums together. You'll keep your carbons together. Whatever. But you split it into half reactions. After you split it, you balance the non H's and O's. All right. And so everything that's not an H or an O, you balance them. That's the first step that you do once you split everything. Okay. The reason why it's H and O, those are the two elements in water, and so we're going to use those in just a second. Step 3, we're going to balance our O's with water. So for every O, we're going to add a water to the other side. Okay, and so you just balance O using water. You just add water wherever you need to add it to make your O's balance. Notice when you do that, you throw your H's off. Okay, that's why there's an order to this. This is step 3. So then now you can guess in step 4, we're going to balance our H's. But we're not going to, how are we going to balance them? We're going to balance them with H+. Okay, so we're just going to use H+ on the side that needs H for every H, okay? So now you notice a new thing. So we balance our H's, we balance our non-H's and O's, we balance our O's, then we balance our H's. Now, the only thing that's left to balance, we've thrown in this extra charge thing, this H+, whatever that means. Okay, everything needs to balance when you do chemical reactions. So not the elements balance, but also the charges balance, okay? That's the important thing to recognize and know. So our next step is we're going to balance our charge. And we're going to do that just by adding electrons. So we're just going to use E-. It's kind of a placeholder, but we're just going to use E- to balance our charge. And again, as soon as we go through this, I think you'll understand what we're doing. But at that stage, after you're done with these, the half reaction, each of them should be balanced. They should be perfect. Okay? And they should look like a balanced chemical reaction. They have this E thing is kind of weird, but it's balanced. Think of it just as charged, not as an E, and there's no E's on the other side. E's, okay? Anyway. Now, what we're going to do, we have two half reactions, and those two reactions each have E's in them. And you know, my chemistry teacher used to always tell me, you can't buy E's at the store. And I guess you can't. You can buy them from the power company, but you can't buy them at the store. And so the E's have to go away. They can't be in the final thing, all right? What you should notice, what will happen every single time, so if you did it wrong, you know, you're going to have something wrong. Your E's, you have two half reactions, you have E's in both of them, and they should be on opposite sides, okay? Doesn't matter which one's which, but they should be on opposite sides. So mathematically, we should be able to cancel them out. And we make them cancel out by making the number in front of them the same. So we'll make the coefficient in front of E minus the same. Okay? Again, that'll make sense when we do it. Now, we add together, add half reactions together, reduce and simplify. You should be able to get rid of your E's if you did it right. Your E's should go away. You know, if you've got 20 E's on the left, you should have 20 on the right. And they cancel out, they go away. Okay? So if you have 12 waters on the left and 8 waters on the right, you get rid of the 8 on the right and you have 4 now on the left. Okay, so it's kind of mathematical, but just, you don't have to think of it mathematically. Just think of it as, you know, just make it, simplify it, reduce it, simplify it, based on what you have. Okay. That's for every reaction, whether it's acid or base. Okay? We've done everything the same up until step 7. Now we're going to add the part, you know, for step 8, in acid. In acid. Add H2O to each side for every H plus. And then combine H plus plus H2O goes to H3O plus. So we're going to rewrite our H pluses. Instead of calling them H pluses, we're going to call them H3O pluses, because that's more chemically correct. That's really what's happening. And so, you know, we did this method as a simple method. It's a little bit easier, I think, a little more straightforward than what's in the module. But it does introduce this extra thing that we have to do at the very end. Okay? So just think of every H plus H2O and make H3O plus. And then on the other side, you just have H2Os extra. And then, again, reduce and simplify. Okay, and then in base, for every H plus, we're going to add OH minus to both sides. That's the important part. And you know, for both of these, to each side, to both sides, whatever you want to say. Okay, so we're not changing the balance. We cannot unbalance our reaction. We've already balanced it, so we can't unbalance it. So now, this will take advantage of H plus OH minus goes to water. So on one side, you'll have this happening. On the side where your H pluses are, you're gonna make water. On the other side, you'll have OH minus, and that'll signify that it's in base. This is base. And that's it. That's the process for balancing chemical reactions, balancing redox reactions. Next video, I'll do another video. I'm not going to put it in this one, but in the next video, I'll do some examples. I'll just show you how to go through these steps.